Good morning, everyone. I would like to introduce to you a paper in progress on modeling temporal uncertainty in historical and archaeological datasets. And I see that it is highly related to the previous paper. In fact, I use some very similar methods, or we use very similar methods, but I think that the previous paper made the implementation in R, while most of our code is in Python. Originally, I thought that I will speak mainly about ancient Greek inscriptions, but later on we decided that we focus mainly on Latin inscriptions, a dataset of Latin inscriptions, because they are open available, so that's also easy to share everything with you concerning the code, and so etc. There is a bit link below, so if you will follow the link, you can easily get to the slides for the presentation, and there are links to all the resources. So the paper is a part of a collaborative research project based at Aarhus University on social dynamics in the ancient Mediterranean. The project focused on macrohistorical development of the ancient Mediterranean, especially social complexity. It focused on employment of various proxy material data as proxy to capture these changes, and at the same time the project is, so to say, meta-theoretical or methodological oriented, because it wants to develop a reusable workflow for a collaborative computational project like this in humanities and social sciences. Everything what we are doing should be reproducible, and the data we publish should be following fair data principles, and so on. So what is the dataset of inscriptions we are using here? So these are inscriptions from the epigraphic database Heidelberg. There is more than 81,000 of them. They are available via an API and XML files. We combine these two resources because the API does not offer all additional variables. Most of these data are geocoded, what is not of so much importance today. Most of the inscriptions are in Latin, but there are also some Greek inscriptions, and in almost 60,000 of them we can proceed with some dating information, and we will actually focus on this subset of the inscriptions which contain at least some information about possible dating. So we work with this dataset and also with other datasets in our project in Python and in R. This particular project is mainly based on Python. We work with Jupyter notebooks, and you can get to all the scripts under this link, under the first link, and in the second link you see the analysis, etc. If you have the bit link, then you can easily get to all the resources, or just visit our GitHub and it will navigate you further. So here, to give you some impression of the spatial distribution of the data, you can see that most of the inscriptions, because they are in Latin, are from the western part of the Roman Empire. And what we mean by dating of the inscriptions, so what information is there. So the dating information in this dataset is coded by means of two numerical variables. The number express individual year, typically, not before and not after, so they define a sort of interval. As I already mentioned, almost 60,000 from the whole data set have at least one of them, typically not before, and in some portion of them the not after value is missing. It might be, we consider that perhaps this represents the post-quem data, but it's not the case. In this case, we just consider them as if the not before and not after value would be the same. There are some very common values, like not before equal to 101, or not after equal to 300. In the first case, that's the beginning of the 2nd century AD. In the third case, is the end of the. In the second case, is the end of the 3rd century AD. So definitely, this information here is based on this information about century. The dating was originally expressed as century, as is explained here. So the meaning of the not before and not after seems to be, in most cases, a numerical operationalization of verbally expressed interval given by a domain expert who was coding or transcribing the data, digitalizing them, commonly using reference to centuries, like 3rd century AD, or specific phases of the centuries, or common historical period, like reign of country, of particular emperor, etc. So the interval here is the interval within which was the inscription created. To produce an inscription, it typically takes less time than a year. So usually an inscription was created within 1 year, singular year, but in most cases we just don't know which one it is. So not before and not after are here to express the uncertainty of the expert concerning the date, so to speak. Once we have not before and not after, we can look at the interval as such. So it has the property of a certain duration, and again there are some common values. There is more than 12,000 inscriptions dated by duration equal to 100 years. That means basically a century. So in almost 60% of cases, this duration of the interval has 1 century or more. So the crucial question is how to analyze temporal trend within such data, which is something very similar to what has been part of the previous presentation. Our questions might be like this. There is an obvious decrease in inscription productions in the 2nd century on, but we want to ask when exactly this decrease started. Is it in the second half of the 2nd century or in the first half of the 3rd century? And we can compare this across provinces. When did different provinces witness a peak in inscription production? Or if there is a temporal pattern we observe as associated with certain subset of inscriptions, like inscription containing certain words, certain phrase, or certain combination of words. That's actually the tremendous task we have to look at the textual content of the inscription and look at the changes over time. So how to approach these intervals, these broad intervals especially? The first and most straightforward approach is to adopt the average value defining the interval between the not before and not after. That means that if we have 101 to 200, the interval defining 2nd century, then the average value would be 150. The disadvantage of this approach is that it's actually biased the data toward peaks in the mid-centuries. So that's not a desirable outcome. A second method, which is quite common and which was presented in the previous and which is also related with the 3rd method, is this heuristic analysis, which can result in the heuristic sum. So for each inscription, we define a probability of its appearance in a particular period, and then we can combine these probabilities for all data set and look at the curve changing over time. A 3rd approach is somehow related to that, and it's combining these probabilities to produce various versions of the data set in a form of simulation. So this approach, our approach is here inspired a lot by the work of Enrico Crema, but we implement the code on our own and hopefully do some stuff a little bit easily to understand. And and we are especially focusing on within what Crema defines as within phase uncertainty. That means that we already have the intervals specified in this case of the data set, and we don't care so much about if the coding itself is proper. So here's the summary of the heuristic sum, and here is the summary of our heuristic approach. So for each inscription in the dataset, we have the dataset in a form of a data frame, having the number of inscriptions as the number of rows, and almost these days the dataset has, in our case, 70 columns, and so we have this column for not before and not after, and we just produce random dates within this interval defined by not before and not after, following certain distribution. We experiment with trapezoidal distribution. I will come to that in a moment, and uniform distribution, because we expect that once an expert decided an inscription was created in a 2nd century AD, there is either equal or almost equal probability that it was produced at the beginning of the century, in the middle of the century, and toward the end of the century. We guess that the expert didn't want to say that the inscription was actually produced with highest probability in the middle of the century. What would be the implication of a normal distribution? So we are now playing with uniform distribution and trapezoidal distribution, and our function might be configured according to both of these. So the second step, when we have the random numbers, by the way, to generate the random numbers for these 80,000 inscriptions in Python Jupyter notebooks run on a server we are using here, takes about 30 seconds. So that's, again, it's not so much computational complicated tasks. And then we combine these random numbers for each individual inscriptions into simulations, so to say. So we have now 10,000 variants of the data set with, in each case, each inscription is assigned to an individual year. And then we can compare actually the data set, various subset of the data set, for instance, and compare the individual provinces or individual type of provinces over time, as I will show you on some figures later on. And we can look at the simulation also in this way, as that's very similar to this heuristic sum approach, where you actually see they assessed in respect to certain time blocks. And having the data in this form, you can also do some basic descriptive statistic. But perhaps so here is a visual representation. In this case, it is for the whole data set, and it compares all the three approaches I mentioned. You can see that there is a substantial overlap between the heuristic sum results and the simulation results. That's a good thing, but things become more complicated when you turn to a particular subset of the data set. Like in this case, we look at the inscription of the type acclamation. And so looking at the data, we can be very confident that there was a rapid decrease between the second half of the 2nd century, 4th century, and the beginning of the 5th century. But we are much less sure about what happened between 180 and 480 because of the variance across the simulations. So, for instance, in case of 11% of the simulations, from the 1,000 simulations, for this subset of the data sets, there is a higher number of inscriptions dated to the second half of the 2nd century than to the first half of the 3rd century. So that's opposite to what we see just by looking at the heuristic sum trends. So having the data in this form and the result in this form, actually the next task is to do, when we will do a statistical modeling, comparing some patterns in this data with some patterns in some economic data or so on, we actually have to look if the significance of the statistical coefficient persists over all the simulations we have, like imputations of the data set. So here is a comparison of various Roman provinces, visualized, the distribution visualized this way, and it becomes, at this moment, it actually becomes interesting, because you can see that, for instance, in Hispania, the peak in the inscription production is quite much earlier than, for instance, in Germania, where it is at the end of the 2nd century and beginning of the 3rd century. It's quite clear here. So this way you can actually see some trends over time and space. And you'll see there is a lot of variance and where the trends are robust. And you can access this statistically later on. But the next challenge, we don't want to use this only for this EDH dataset, we want to adopt the same approach for assessing other datasets. And as I already mentioned, we don't work only with Latin inscriptions, but also with Greek inscriptions, as already the title of my presentation suggests. So there is this dataset of more than 200,000 inscriptions, which are mainly in Greek. And applying some functions we developed, we were able to extract the data information for 130,000 of them. So that was the biggest task here, was actually how to translate the verbal expression of a date, like beginning of the 2nd century BC, to these numerical values, similar to what we have in the EDH, what the creators of the EDH database did for us. So we had these struggles, and now we have the functions to produce this, like how to define mid of the 4th century BC, for instance. But in this case, we have it in a function, and we can reparameterize this function, so we can modify this if we find some more appropriate way how to do this. And again, in this dataset, on the left side, you see the EDH dataset, on the right side, the PHI dataset, and the most common value of length of the interval, so this duration interval. Again, we see that there is a lot of data dated to this 1 century duration, and again, a lot of data using 2 centuries duration. And finally, here is a comparison of the two datasets. Visually, something what we wanted to do a long time, but we were sure that we definitely cannot approach the approach based on averages. So we first developed the heuristic sum, and then we tried to proceed further with developing these models. And again, here there is this regional comparison. You can see that the peak in Attica was in the period of classical Greece, while the peak in Asia Minor, by orange color, was definitely later during the Roman period. And so once we have the data in this form, what the task we have, so use the function to explore and analyze textual content of the inscription and how it's changed over time. The ultimate goal, at least for me, is to apply here some distribution semantic analysis of the inscriptions to look at changes of certain themes over time. And methodological speaking, we want to improve the methods to make them useful for other data sets and other users, hopefully to make the functions as much understandable as they can be. And we want to publish them as a Python package at the end, and to demonstrate the usage of the package by means of an article. But it's now a work in progress. So thank you for your attention, and looking forward for your comments, feedback,